I want to show you something that I think is pretty amazing. I've got this algorithm here, which is scooping up some rooms, like these ones, these living rooms, and is building the walls out, right? So it figures out what rooms are touching what rooms, gives each wall a code, runs one more little process. If the walls are sitting on top of a grid line, it makes them party walls. And if they're on a balcony, it makes them like a glass door. If they're on the facade, it makes this sort of kind of rhythmic, elegant window pattern. And the rest of the walls are basically just wide internal walls, except for the ones that are touching the corridors are also party walls. So you can see those great ones there. You're doing a lot, right? And you may say to yourself, that this is what's doing it. This is the actual algorithm here. That looks crazy. I'm never going there. But if you're a large firm, you'll probably have someone who can write that algorithm within the firm. And maybe they've written the algorithm, right? They're the algorithm guy. That's what I used to do when I was an architect. I was the algorithm man. But now I want to show you, this is the crazy part, just how quick this is to do. So I'm going to turn off run. So I've added this little toggle that stops the algorithm running. And the reason I've added that is because it's slow to run. So I've click run off. And now what we're going to do is we're going to build a new apartment from scratch. So let's say we get a call and a client wants to build 12 apartments. And I'm the algorithm man, not the apartment man. So I'm going to hand over to the apartment man. Now, it could be in the same Giraffe project. It doesn't need to be. For the sake of, this, we'll put it there. And we're going to build up from scratch an apartment. So let's do a couple things. Let's delete that. Let's build a rectangle, a rectangle, a rectangle, a rectangle, and make that one, that one, that one, that one, that one. That's my bathroom. That's my balcony. That's my living, and that's my bed. And you can see I'm scooping up these properties because these all have an offset. They have an offset of 0.1, which means if the two guideline offsets are touching each other, that's 200 between those. Now they also have this walls parameter, which is currently clicked to true, right? So what we're going to do is we're going to build up our apartment typologies, put them together as a building, and then run this algorithm and see if we get an output. So our apartment typologies, let's just say the bedrooms have to be 3.2. So I'm going to type 3.2 minus, then snap. Where's my snap gone? Friendo. Okay, good, it's working. All right, let's do it this way. So I'll type 3, I'll go rectangle 3.2, and then let's say the bedroom is 3 meters deep, like that, and I'll go Y. Okay, so that's my first bedroom. I'm going to hold a copy down, snap to it. This is going to be my bathroom behind my bedroom, and it doesn't need to be 3. Maybe it can be, I'll go 1, so it's 2.2, and then can I get 2 minus? Can I get this snap to work? There we go. 2 meters wide seems a lot. Let's go. Should we go 0.4 in? There you go. 1.6 by 2.2. There's the bathroom. And now our living. So let's just drag a copy of this, snap him to there. I guess he snaps down there. 4.6. So if we go something 0.4, 1.4, 2.4, 2.4. We get a 7 meter deep living, and let's go 0.2 wider, so it's 3.4 wide. And now we've got this relatively enormous balcony, to be honest. Salavi. Okay, now this needs to be that. And I'm using the Y key over there just to drop the properties. And let's say that's our 1-bedroom apartment. Now, there's going to be some risers and some storage, and also I'm not even that good of an apartment person. So your apartment design person, I'm an algorithm person. Your apartment design person's doing that. And then let's say there's another apartment, I guess, something like this. I never know quite how they do it. They're always so smart, these apartment design people. So I'll go 1 and 1 and 1, and I'll snap that guy down there. And that to there, and then this needs to go 1, and then that needs to go 1. and then this needs to come out to here. It always looks something like this. There's always these tricks, and I don't know them, but some people do. So that's my 2-bedroom. Maybe let's snap that out ever so slightly. Let's say another 0.6. And I'm kind of belaboring this just to show you can kind of do these bottom-up sort of precise moves in Giraffe. The way I always used to work was I just snap it around, and then, a bit of that. There's my apartment. Rough. Or just a box. But we're doing some internal walls here for the sake of argument. And I think in these situations, they do something like this and put these boys, another sort of the executive wing. So here's the master and this. And then I don't think you need, maybe this is more of you do another study. Let's say there's a really nice apartment. So, well, maybe this is another living, right? But there's a study. This is being sold as a study over here. Okay, and that's of concern. That should be snapped. That should be snapped. And that certainly should be snapped. So we just need to snap everything to the right thing. Easy to snap to the wrong thing. There we go. All right, so we've got our apartment types. We're 6 minutes in. And now I guess we start assembling them to a building. So we'll do that. Groovy. And then we can grab this guy and spin him around. Oh yeah, let's do that. Let's say the side's an odd shape. Let's say the side's like this. Let's pop a core in. Something like this. 2.8. Is that big enough for a core? Maybe we could just do something like that. And then I guess we can do a corridor like that. All right. So we will call this corridor. I'm going to hit Y here. Now that's going to be silly because it brings the flow. Our flow is actually hosted on this corridor. And so now it's here again, so I'll just delete it. And then I will grab the core. Okay, and if we hit T, we can see we've got this kind of 3D view. Now, is that sort of enough? Okay, yeah. So that guy's front door, I presume. It's a bit silly. Anyway, let's not solve the planning issues. Because, as I will repeat, I myself am not an apartment expert. But I don't think this guy can. No, corridors do it. Now, what we need to do is we need to model this into a model. And all we do is we selected all the walls are there. Oh, there's one further instruction we need to do. We need to actually draw in the party walls. So I'll do, this is a party wall. Show between those two parties. And let's say we have we want another concrete blade wall somewhere, and it can be this one. Now, the way the algorithm works is anything that's touching a corridor is going to end up as a party wall, as a concrete wall anyway. So we can sort of rest easy on that front. All right. So the apartment guy says, hey, I'm done. It's 8 minutes 43 in, and this is looking good. And, we've all had a good time. Can we run the algorithm? We click the run button and bang, we get a run. Now, what the run has done is it's applied balcony walls. So this is the one living, which is 3 by 3.2. And now maybe we're finessing. And we say, well, let's extend it like this, something like this, make this this room more generous now that we've seen it in 3D. This looks great. This is not generous enough here. This feels, for this apartment. So let's move everything down here. Oh dear. I've grabbed something back there. Okay. So yeah. Move this guy over here and we'll extend the living. And there we go. Get something cool. And maybe we can pull this guy out a little bit. There we go. That's really cool. And I guess this guy could easily be pulled out. Something like that. And I guess so could this guy. Something like that. Something like that. something like that. I'm mucking about just to show you the flexibility and power of the algorithm. I don't know if I'd love that shape, but that's okay. And we're now within 10 minutes, and we have got this geometry on the screen, and we can now, no problems, send this thing to an engineer or a real estate agent or a rendering firm or anyone, and get very, very rapid feedback on this thing's feasibility. We've got a model, centerline model, where the core position is. We've got a whole bunch of stuff here that is extremely powerful, and we've got full parametric control over it in 10 minutes, which I think is crazy. I think this is crazy. In my past life, I would just never have been able to get anywhere near this level of speed and power. And so have this platform work like this as quickly as it is, it's just so cool. And it works too, like when you're seeing real life apartment designs and they've got these little kinks and these little, this bits and that bits, like because, the riser didn't work and this didn't happen and blah, blah, this algorithm's robust to it. So as this thing designs, we're going to get all those little things happening. Okay, so let's say we're happy with this, and now we're going to do an export. How do we export this? So I would now, I would retire the apartment man or lady. They can go, job done, 8 minutes, good to sign off. We've got the views, we've got the, all the things, all the design considerations that needed to be made, they've made, and everyone, blown away. So now we're back to the BIM process, fellas, and we need to get this data into Revit. And there's a couple of ways to get it into Revit. But I'm assuming you're a large firm here, so I'm assuming you've got a very good grasp over data. And so I'm going to take you through how you do it. And I'm going to delete this. I'm going to delete that building. I don't need it. Let's say this building was cancelled. This building was the one that the people wanted at 4 levels. So we now somehow need to get all of this information out into Revit. So the way we do this is we get into the flow and we're just actually going to export the text data. So majority of this logic over here, there's some logic in terms of applying wall types to these walls, but the majority of it is just is handled by this algorithm over here, which does internal and external walls. That's all it does. But once that's done, there's not heaps more to do. And so what we're going to do is read the property. So this thing comes out looking like a JSON, which it is, keyed by internal walls, and then a big list of internal walls, and external walls, or external walls. So in this instance, actually, that's very useful when you want to do different things, very convenient. In this case, I'm going to read both of them and just flatten the list. So I'm just going to get a big array of walls. And then I'm going to unproject those walls just so I get you a JSON. And again, I'm going to flatten that list. Just want to be a little bit, I actually don't, this stuff too. High fence. And I am going to get this flattened list, right? And now this flattened list looks like this, the actual structure, once we've unprojected. And unprojecting means you take it from world space to Cartesian space and back and forth a few times, and you get this projected key and you get this geometry key. So this is lat long and this is Cartesian. So I just had a chat with the guys. What we're going to do is we're going to have a eval section, and that's going to produce this data structure for us. But our data interop people have told us that they really want to see the following properties on each wall. They want to know how high it is, what its width is, and what its wall section is. So currently we just have is internal and adjacency code. So this is a balcony to a bed wall, and it's an internal wall. It's not a facade wall. So in our design, that's one of these. So there's bed in pink, balcony in white, and this wall gets coded like this. It gets turned into sliding doors. But that's actually going to happen in the BIM package. So they're going to read all this balcony beds. They're going to apply to a slider, and maybe there's a formula there. You apply, a standard type slider right to the middle. See, so I don't need to represent that now. It's actually not critically important, and it's not critically important to bake it in and pull the geometry across. So I'm just going to write the properties. So the properties, I'm going to write a wall height property. So I'm going to grab every item in this list. I'm going to map over it. I'm going to write 3.1 to the wall property, 0.2 to the width property, and rectangle, the word rectangle, to the wall section property. And then out of it, I get this, which is the same data. You can just see in the properties, we have those wall properties added. So this one ends at stroke width 2. This one goes stroke width 2, but then 3.1, 0.2, and rectangle. But we still have his internal and this adjacency code. Right, so it's just slightly enriched. It's enriched in exactly the way it's been asked to be enriched. And now I could bake this in and then export that geometry, but I am simply going to copy and paste this in. I'm going to copy paste it into Visual Studio Code and send the file. So if I do that, and I paste, that's what it looks like. We'll close this, go back to line, and looks like this. Now, it's actually not canonical GeoJSON. Canonical GeoJSON goes like this. Oh, how good is whoever did that? That was one of the AIs acting. That's crazy. That is actually crazy, but very useful. Thank you. So I didn't know it's type feature collection, all uppercase, and then features and the array of features. So now this is canonical GeoJSON, but it's got this special additional key called projected. All right, so we're 17 minutes in, and we've handed this job back and forward between the firm. We did our own building, and then we deleted it, and we went back to original building. And now we've exported the data that we want to instantiate this in Revit or Tekla or wherever we're going. ArchiCAD, we've got the center lines plus the information of the walls plus the adjacency code so they can actually type the walls. Pretty crazy, pretty cool.